This is Algebra 3, Test 1 review. Check, 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 mic, 1, 2, 3. We got it. Okay, the most missed question on the review, and I'm going to take for granted that you guys have this sheet in front of you, that you guys can pull up. I think that if I pull it up, it's right here, and we can scroll down and look at different sections and that type of thing. So if you need to, I guess you could go back to this part of the video and pause it and then go back and look at the question if you had to. All right. So the most missed question we had was number 19. Number 19 gives you a trapezoidal figure. Looks somewhat like this. Okay. We got 8, 4, 4, 6. These are right angles. Okay, through here. Let's see, it says find the volume of the cone whose base is shown and whose altitude is 9. Okay, 9 meters. Okay, so the formula for finding the altitude, I know it says cone, it should have said pyramid. It doesn't change our formula. Our formula for this is area of the base polygon times the height or altitude divided by 3. So to find the area of this, what's kind of handy already is that these two triangles have the same dimensions. They're both 4 by 6s, which means I can take the one from the right, flip it over, put it over on the left-hand side, and finish out this and delete that, right? Right, and I could end up with something like that. So I've got a 4 by 6, which is 24, and I got an 8 by 6, which is 48. And I can add those two things together to get the area of the base. 24 plus 48 is that 60? No, 72? 72? 72. All right, so that's 72 meters squared. That's the area of the base. All right, so I've got 72 meters squared times 9 meters divided by 3. So 72 times 9 divided by 3. Should be 216 meters cubed. And I'm going to tell you that on the test it's going to be a very similar question type. Okay, but let's say for a second, what if they were different triangles? Could I still have figured it out? Okay, yeah, I could have. Now, essentially, the reason I fast forwarded so much is that the area of a triangle is base times height divided by 2. So I'd get 4 times 6, which is 24, divided by 2 is 12. And then I'm doing it again over here. So I'm getting another 12. 12 and 12 was 24, the same as 4 times 6. All right, just help me to skip. But for your sake, you might want to look at it as 2 separate triangles that I'm adding together at the end. So 6 times 4 divided by 2 is 12. 6 times 4 divided by 2 is 12 plus 48. I'm still getting to 72, right? How many of us just simply forgot that formula right there? Okay, at least a couple of us. All right, so does anybody have any questions about that? I feel like I went too quickly, missed it? No? Okay. All right, so the next most missed question is question number 9. Question number 9. All right, it says add 3 plus x over 1 minus 2 over x plus 1 over x times x plus 1. Okay, so we have 3 fractions that we want to add together. In order to add fractions together, what do I really need to have? I need a common denominator. Okay, now we can go ahead and use the associative property like this, if we want to, and go ahead and add those things together. But even here, the common denominator is still this right here. Okay, because in order for me to get a common denominator, in order for me to get x, I can't just say plus 1, right? That doesn't really work. It doesn't work like that. I have to multiply, right? So on this one, I'm going to have to multiply by x over x, and in this, I'm going to have to multiply by x plus 1 over x plus 1, right, which is this denominator. So in so doing, I am getting still a common denominator between all three, correct? So here I'm getting 3x minus, now notice here I have to distribute, right? And I guess now I'm going to be working with purple. Okay, so 2 times x plus 1 is 2x plus 2, right? Or minus 2x minus 2, right? Plus 1 over here. Okay, my denominator is x times x plus 1. All right, what's the next step in all this? Combine like terms. Okay, so in combining like terms, I have 3x minus 2x, which is just x. Negative 2 plus 1 is minus 1. X minus 1 over x times x plus 1. And let's see if I'm looking at my answers. That is it, my friends. That is it. Nothing else to do. So I think probably the part that we might have struggled with there is getting a common denominator. Okay, now that we know how to get a common denominator, would that have been a lot easier? Okay, hopefully, I'm a little worried that we might struggle with that part right there in getting this. Does everybody feel like they can do that successfully? Okay, all right. Let's see, the next one that kind of comes up on our list, next most missed, is number 20. 20 on our paper. It says evaluate. We have x cubed minus 2y squared plus 2 times y minus x times 6x to the 5th plus 3xy to the 4th plus x squared to the 0 if x equals 3 and y equals 4. Now, there's one part of this question that I absolutely love. I love the 0 exponent. Do you know why? Because it makes everything 1. Okay? Because I am taking x to the 5th, multiplying it by 0, getting 0. I am taking x to the 1st times 0, getting 0, y to the 4th times 0, getting 0. I'm taking everything in here and getting it to the 0 power, which means it's 1. And 1 is not going to change the value of this. So I can drop that whole thing. That whole big complicated mess goes away. Now what I can do is I can substitute, right? All right, so in parentheses, 3 cubed. I want to make sure I use parentheses when I'm substituting. Okay, because sometimes I substitute in negative numbers and I want good habits. 2 times 4 squared plus 2 times parentheses 4 minus 3. Okay, now that might be overdoing it a little bit with the parentheses, but I'm just trying to be safe. So what's the first thing that needs to happen here? Well, here's where we go back to order of operations. It's the reason order of operations is so important. PIMDOS. What's P? Parentheses. So even before exponents. So first thing I'm doing, 4 minus 3. Okay, 4 minus 3 is 1. Okay, I can bring down everything. I got 3 cubed minus 2, 4 squared plus. Okay, now what's next? Exponents. What's 3 cubed? 27. 27, so I got 27 minus 2 times 4 squared plus 2 times 1. Okay, you don't necessarily have to split it into as many small steps as I'm splitting it into, but I'm trying to make sure that you can follow along, right? We don't get lost in here somewhere. Okay, 27 minus 2 times what? 16. Notice I didn't do 2 times 4 and then square it later, right? We did the 4. The 4 is being squared. Okay. At some point, you could probably dropped off the 1 up there a long time ago and just put a 2. That's fine. Now we're left with negative 2 times 16, which is what? Negative 32 plus, we're going to go ahead and just make that a 2. Okay? Okay, because that's what we know it is. So we have 27 minus 32 plus 2. 27 minus 32 is probably negative 5. Negative 5 plus 2, negative 3. Number 20, let's double check our work. Negative 3. Okay? Easier than what we were making it. How many of you didn't catch that to the 0 power? You went all the way through the process of taking everything to the 0. Did you end up getting it right or was it wrong? Got it wrong. Okay? So hopefully if you see that question on the test, it's way, now I'm not saying that there will be a 0 there on the test, but if you do, that'll be a big bonus, right? All right, so what's next after that? It looks like we have a tie between 16 and 3. Let's go ahead and do number 3. Number 3. It says, in a preference test, 38% of the people polled like the art of Vincent van Gogh. If 874 of the people polled liked Vincent van Gogh's art, how many people were polled? Okay, so 38% of people like Vincent van Gogh, right? Okay, so basically what we're saying is 38% of people equals 874, right? Okay. What does of mean in math? Multiplication. What do I want to do with percent? Change it to, which is? So 0.38. Can we use P for people? Okay, 0.38P equals 874. If I want to know how many people were polled, okay, what do I want to do? Divide by 0.38. What is 874 divided by 0.38? 2,300. Was that easier than what you were making it? Hopefully, all right? Set it up as a proportion. And there, did you get it right? Yeah, you can set it up as a proportion. I just think that this is maybe, for me, it's sometimes just how your brain works. I hate to be that way as a math teacher, but you know, there is more than one way. All right. So that is a way. All right, let's go down to number 16. Am I going too quick for anybody, or do we feel it? What? No? Oh, okay. I'm good. He good. All right. All right, an equilateral triangle has a perimeter. Okay, so equilateral triangle, it's not a right triangle, right? It's equilateral. What do we know about equilateral triangles? All angles are the same. All sides are the same, right? So I'm getting something that looks roughly like this. Do we know what the angle measures of an equilateral triangle are? If all angles are the same, then every angle must be what? 60. Why 60? 180 divided by 3. So I got 60 degrees here, 60 degrees here, which is always good news, right? Because we might end up working with a 30, 60, 90 triangle in here somewhere. All right, well, 16, an equilateral triangle is a perimeter of 6 kilometers. Okay, so the distance all the way around is 6 kilometers. Okay, has an area of radical 3 kilometers squared. We want to find the altitude of the triangle. The altitude is this line right there. Okay, so there is more than one way to solve this. How many of you, by raise of hands, are familiar with your 30, 60, 90 triangle ratios? Not many of us. Okay, all right, that's fine. Okay, if we know each side, or sorry, if we know what the perimeter is, then do we know what each side is? How would we find that? Each side, the whole perimeter, the total distance all the way around this triangle is 6 kilometers. So can I find out what each side length is? By doing what? 6 divided by 3 equals 2. So I know that this is 2. I know that this whole length down here is 2. I know that's 2. Okay. What ends up happening with this right here? What does that become? 1, right? Because it's going to be a bisector, right? Word question is, what is this? All right. We do have, I guess, even a couple of other things, is that we do know that the area of a triangle is base times height divided by 2. Well, do we know what the base is? What's the base? No? Well, the whole triangle. You could do it either way, I guess, but what is the base here? 2. Okay. And do we know what the area of the triangle is? What is it? Okay. So what we're saying is that if this is 2, and we don't know what the height is, but we know if we divide it by 2, we're going to get what? We get an area of radical 3 kilometers, right? What happens with the 2's in this equation? Cancel. So what is my altitude? Radical 3. All right, let's check. This is what question was this? Number 16? 16? Yeah. Height equals radical 3 kilometers. Now, that same thing would work if you remembered that this is a 30, 60, 90, because we're at 1, 2, radical 3, or 1, 2, 1 radical 3. Okay, well, does it still get to radical 3 kilometers? So we can solve it using the area formula, which is what we did here. Okay, or if you remember your 30, 60, 90 ratios, you can solve it. Okay. Later on, you'll figure out how to use things like sine, cosine, and tangent to solve for those types of things. But that's maybe going a step beyond what we need. Okay, so let's see. That was 16. Now we need to take another step down, and let's look at question number 13. Are we hitting most of the ones that you guys have, right? Okay. 13. 13 gives you a picture. Let's take this a little bit further down. Something like this. We know we got that. We got 9. We got E. We got F. We have G. We got 16. We got 12. Now, I say that we need to do this question, but really, I mean, less than half of us missed it. So I do still feel pretty good about this. But let's see, what are we asking for? We want to find E, F, and G. If I split this into 2 separate triangles, a big triangle and a smaller triangle, here I would get 16. I would get F plus G, right? And I would get 9 plus E there, correct? Okay, and if I had a smaller triangle, I'd have 12, 9, and F. What's the easiest thing to solve for? F, right? Because Pythagorean theorem. 9 squared plus 12 squared equals F squared. 81 plus 144 equals F squared. What's 81 plus 144? What are we at here, number 13? Did somebody get an answer? 225? 225 equals F squared. We want to square root 225. F equals 15. Okay? That allows me to substitute there, okay, as well as here, 15 plus G now. Okay, there's 15. But because this is a shared angle, right, and these two angles are congruent, then I know that the triangles are similar through angle, angle, angle similarity postulate, right? So for the rest of this, I can set up a proportion because they're similar. Corresponding sides of similar figures are proportional. So let's see, we can do 9 plus E over 16 equals 9 over what? 12. Okay? All right, so what's 9 times 16? Did you say 16? 144 equals, now, what do I have to do between the 12 and the 9 plus E? Distribute. So 9 times 12. 108 plus 12E. Okay, what's next? Subtract 108 from 144. So what is that? Is that 36? 36 equals 12E. That looks a little easier, right? Just divide by 12. What does E equal? E equals 3. Okay, E equals 3. Okay, so we've got that. All right, so then we just need the last part. Okay, so we know E equals 3. So we actually know, because E equals 3, that this side equals 12. And if we had to, what could we do? If we had to, we could still use the Pythagorean theorem. Because we know this is 12, we know this is 16, we know that's 15 plus G. I could still use the Pythagorean theorem there. It might be a little complicated. So probably what I'm going to do is just continue to use proportions, right? So we can do 12 over 16, or sorry, no, we need to actually use the part that we need, which is G. We can do 15 plus G over 16, okay, equals what? 15 over 12. Okay. What's 15 times 16? 240 equals, and then we have 12 times 15. What's that? 180. Okay, equals 180 plus 12G. Okay, subtract 180 from 240. 60. 60 equals 12G. Divide. G equals 5. Okay. G equals 5. So let's check that with what we have. E3, G5, F15. That is a time-consuming question, right? So my recommendation is that if you think that you're going to struggle with it, I probably wouldn't put it on my list. Okay? Let's see, what's next? That was 13. And we're getting down into our 4s. So we have a couple of 4s. Number 8. Number 8. We have 4 times x plus x to the 0 plus 2 equals 3 times 3x minus 1. At this point, I'm kind of going to take over, maybe not ask as many questions. This is going to be 4 times x plus 1 plus 2. Okay? I don't necessarily cancel it out in this case, okay, because it's not all multiplication. Over here, I'm going to get 9x minus 3. Okay, this is 4 times x plus 3 equals 9x minus 3. 4x plus 12 equals 9x minus 3. Subtract 4x. Add 3. 15 equals 5x. Divide by 5. X equals 3. Okay, questions there. What mistakes did we make? Can anybody tell me? No. Nothing anybody's going to admit. Okay. All right, what do we need next? That was that. Let's see. Looks like number 18. Number 18. Number 18 gives me a circle And that should be in the center of the circle. Here I have 62 degrees and a radius of radical 5. Okay, and it wants to know the area of the shaded region. In order to find the area of the shaded region, it is pi r squared times measure over 360. But notice that I have two sectors. So what I'm going to do is I'm going to include both sectors in my degree measure. Okay, because I could just as easily turn that around and get everything together. My radius is radical 5 squared. My measure then becomes not 62, but 124. Right? Okay, so radical 5 squared is 5. So I have 5 pi times, let's see, 124, let's see, we're on 18. Okay, times our stuff there, let's see. Should be like 31 over 90. Okay, and this whole thing is going to simplify to 31 pi over 18. And I don't know if they give you anything in this. Centimeters squared. So solve your answer in terms of pi. If you give it to me as a decimal, ask tomorrow, but I'm telling you solve it in terms of pi. Okay? All right, so those were the biggest questions. Everything beyond that, 2 or 3 people missed. What I am going to send you is I'm going to send you this. I've already got it on my computer. I'm going to send it to you. All right, it is all of my work for this review so that you can go through and look at it if there was a question on the review that we didn't answer today. Okay?